This question is asking us about symmetry of graphs, and it kind of is going to work out the way you want it to. When you talk about symmetry, we say something symmetric if really it looks the same on one side as another. It's kind of convenient that I left this graph up here, but we would say this graph here is symmetric with the y-axis, because if we flip it over the y-axis, it'll be the same. It looks the same on either side. Right. And for these problems, it's going to ask you, are you symmetric to the x-axis, symmetric to the y-axis, symmetric to the origin, which we'll talk about, or neither. So I'll go through the details of this first one and then kind of mention how it works with the other two as well. If we want to see if it's symmetric to the x-axis, right, the x-axis is the horizontal one. If we flip the graph over the x-axis, does it stay the same? Like very literally, is it in the same spot? So if we flip this over the x-axis, it's going to go below, and it's not the same. It clearly has moved. Even though it has the same shape, they're always going to have the same shape, it's definitely moved. So this is not symmetric to the x-axis. Because it moved. Now the way we do the y-axis symmetry is very similar. The y-axis is the vertical one. We take our picture and we flip it over the y-axis. So when we flip this over the y-axis, think about folding a piece of paper. It's going to face this way. It's going to look something like that. But once again, it moved. Right? It's not the same exact picture. So the answer to this one is also no, it's not symmetric to the y-axis. And very literally, it's because it moved. Right. And then the last one, if you want to answer the question, is something symmetric to the origin? What you do, there's a couple ways to think about it, but really this is the best way, I think. If you flip it over both the x and the y-axis. So let's say we take our picture here, we flip it over the x-axis to get it down here, and then we take this one and flip it over the y. So it becomes back here. Is it the same picture? And once again, the answer is no. So let me go ahead and write that one down because a little more confusing. So we take our original picture, we flipped it over the x, which we could already had a picture down for right here, and then we took that one and flipped it over the y, and it moved. So it's not symmetric to the origin. Right, so this one, it's not symmetric to any of them. We would say it's none of these. And that's okay. The next one down here, are we symmetric to the x-axis? Well, if we flip this one over the x-axis, right, the v would come down here because this is the x-axis, so it comes down here. And it's once again not the same picture, so it's not symmetric to the x-axis. It moved. Is it symmetric to the y-axis? And this one you might finally be rejoicing and say, yes, it is symmetric to the y-axis, because if we flip it over the y-axis, this line will go right here, and this line will go right here. So it's going to look exactly the same. It did not move, which means that it actually is symmetric to the y-axis. I can already tell that's not going to be none of those then. And then the last one, is it symmetric to the origin? Well, think about it again. If we flip it over the x, it goes down here. If we flip this picture over the y, it's going to stay right on top. So I'm just going to dash to indicate that's where the origin would go. And it's moved. It's not in the same spot. Okay, so very literally, now you can see when I say, did it move or not? Did it move or not? This one did not move. It's in the same spot. All the rest have moved. And then the last one here that I have, we want to do the same thing. You're never going to do anything different with these symmetry problems. Is this symmetric to the x-axis? Well, if we flip it over the x-axis, this part down here is going to be below. It's going to go up, up, up. This middle part here is going to go up and then come back down. Then this part here is going to be below and come back up. And then this part over here, when it's flipped, is going to go back up. So it's definitely moved, which means it's not symmetric to the x-axis. Now, is it symmetric to the y-axis? If you're on your own paper, it might be better to just redraw the picture or not have this redrawn. Actually, I'll highlight the original one in black, so it's a little bit easier to see. If we take this original and flip it over the y-axis, what you want to think about is this half going over here. Right, so it's going to dip down, and then it's going to go up as we move away. And this half is going to go over here. So the part close is going to be above, and then the part far away is going to be below. And it actually is right on top of the red one, but that's not our original one. So it's not symmetric with respect to the y-axis. The last question is it symmetric to the origin? And one way to really think about this, we want to do both. So if we flip it over the x, it's the red picture. Now what happens if we take the red picture and flip it back over the y? And meaning this part goes back over here. So this little area that's in red is going to go back here. This little area down here is going to go back here. Remember, we're looking at the red one. This little area is flipped over the y is going over there. And this area in red is going to go up. And it actually is on top of itself. It's not moved. Very often, the hardest ones are when it's not symmetric to the x or y, but it is symmetric to the origin. One way to know when this happens is if when you flip it over the x and the y, they're in the same spot. Okay, so if the x flip and the y flip are on the same spot, then it will be symmetric to the origin. That's a handy way to think about it. If they're not on the same spot, then it's not going to be symmetric to the origin.